Okay, I might as well get this started. So welcome everybody to the ArangoDB sort of online meetup. So we're doing it on YouTube this time. So let's see how this works. So my name is Mike Williamson. I run a software consultancy here in Ottawa, Canada. And that means basically sometimes I'm building stuff for startups. And given this is the capital of Canada, occasionally I end up doing stuff for government as well, because it's a fairly big presence in this particular city. So what I would like to do today is I want to talk about GraphQL and ArangoDB. Both of these are projects that are kind of interesting in and of its own, like in its own right. But I'm going to be focusing on GraphQL today. And specifically, I want to dig into GraphQL. What I want to explore a little bit also is I think there's something really interesting that happens when you use GraphQL and ArangoDB together, something that maybe isn't apparent if you are simply using one or the other. So I want to kind of dig into that a little bit as well. So what I have here is basically, I'm trying to capture kind of a pretty typical architecture that I see used in a lot of startups. So we sort of entered this world of a lot of single-page web applications and stuff. Stuff that I see that's being used in a lot of startups is something that looks a lot like this. So in the center of this little diagram, what we have is a fairly standard kind of Rails stack, and I'm trying to show the different kind of components in there. So obviously this is going to include Rails itself, the Ruby language, and then sort of a lot of the kind of architectural, like conceptual stuff that REST provides. So that Rails app is kind of sandwiched between sort of the outer world where all these requests are coming from and kind of the inner world it uses to sort of draw from to satisfy these requests, right? And both of these worlds have kind of changed over time, right? Become a little bit more complicated. So if you look on the left, what we have is this sort of outer world where we have a whole bunch of different clients. The clients, you can see up here, you've got on the left, on the top left, you've got basically some mobile clients that are sort of distinctly versioned, and having to work their way through the App Store approval process, all that good stuff. And then maybe you've got sort of your single-page web application. We'll say, as an example here, we're using AngularJS. So that's going to be whatever version is served directly from your website. So this is always going to be kind of up to date. Then maybe you have like third-party people sort of building some complementary service using kind of your API. So they're hitting you kind of using its API access. So what's happening here is that essentially all of these clients have slightly different data needs and are all going to be asking for sort of different views of essentially the same object, same data. And so if we turn over to the right side of this diagram, what we have is a sort of this inner world where increasingly what we're seeing is we're as the number of super useful APIs keeps expanding, we're seeing increasingly we're drawing from multiple sources and sort of stitching together a response by querying multiple sources of data. So in this, if we were to say that this is an e-commerce example, so maybe we're pulling some sort of purchase history from Stripe, let's say, maybe marrying that with a couple of recommendations for related things that's maybe coming out of a graph store or some graph-based recommendation engine, possibly in its own database, and then knitting that together with some like actual product details that are going to be coming out of, say, like a relational database, some tabular kind of form, right? So I guess what I'd like to point out here is that, in spite of its normalcy, I feel like there's a fair bit of complexity actually going on here. We've just kind of become accustomed to it. And so it's probably worth pointing out that some of the challenges that we face with these things. So the obvious thing is basically what I just said, is sort of this idea of integrating all these different responses from all these different places is a bit of a pain. Sort of on the left-hand side, though, we have kind of this nastier problem of dealing, if we have all these different types of data, all the different attributes of all the different types of data that we have, what we're, with these sort of multiplying number of clients, what we have is we're struggling with this, notion of like different permutations of all those bits of data, right? And so the response that REST kind of gives us, like the architectural pattern of REST, basically has separate endpoints for each resource, but the need for these permutations and different kind of remixes of these few attributes of a user plus the last 5 products that they purchased or something like this. All these little permutations of data that are needed in these client views kind of add up to and end up forcing people to create like a bunch of these custom endpoints. They're all serving some specific permutation of this, all of which is basically just to say that this kind of struggling with these permutations kind of tends a little bit towards chaos. So if we were looking to kind of simplify this problem and improve things a bit, what we might explore here is actually adding a query language. So if we were if we could get all of these clients to all speak the same query language to us, what that would mean is essentially we'd be able to treat them all the same. Like if they're just able to articulate what they need in the form of a query language, we can ignore the distinctions between them and trust that they're just able to ask for what they need, and as long as we're able to execute those queries, then those distinctions all kind of go away. So if we were able to do that, this actually would give us a fair number of benefits, actually. So obviously it would solve this sort of different views of the same objects problem, basically would also give us sort of a solution to another problem that sort of is kind of a pain point with REST APIs, which is sort of fetching related data. So if you had a query language in play, you'd be able to pick up related data all in a single query. And in doing that, we would have solved another problem that's actually pretty valuable, which is minimizing the number of round trips to the server, which is definitely a big win when you're dealing with sort of these bandwidth constrained mobile devices. And another thing that's maybe not quite as obvious that's a benefit here is that in making people, forcing people to explicitly ask for the data that they're interested in via a query language, for the first time this actually gives you some visibility into which parts of your data set are actually both sort of used and useful to your clients. This is another kind of unappreciated but kind of big win in a world of REST APIs where you're basically throwing kind of ginormous blobs of JSON out the door and letting the client pick the 1 or 2 attributes out of that they're actually interested in. So it probably won't surprise you if I tell you that the QL part of GraphQL actually stands for query language. And it probably also won't surprise you if I were to tell you that companies like Shopify, which has its headquarters not far from here, are actually using this. They're adding it to their existing tech stack to solve exactly these kind of problems. But what I would say for for your consideration would be that in simply adding GraphQL to your existing tech stack like this, it can certainly solve some problems. I would say that it sort of passes up on a kind of a broader opportunity to simplify things. Because what's really interesting about GraphQL is I think that it really opens the door to actually replacing a lot of other parts of the stack we've just shown, and I think this capability of replacing stuff is actually sort of the connection that I see that sort of joins these two projects, GraphQL and ArangoDB, right? Both of them have this capability to not just be yet another thing that you add to your tech stack because it's cool, but it actually, gives you the opportunity to actually replace things and remove other parts. What I would say here is that if you were to embrace of like GraphQL and ArangoDB, basically you could create the same kind of application as we started with basically just this. At this point you've eliminated not just Rails and Ruby, but you've also eliminated REST. You've eliminated at least one or probably two other databases and the query languages that go with them, all the quirks and scaling stuff that you need to know about each database that you're thinking about, and I guess web frameworks, all of this other stuff. It's really a chance to kind of radically simplify what you're doing. You can take this even as sort of a step further, I think, by sort of embracing JavaScript like across the entire stack, which is absolutely a possibility because of the awesome JavaScript support that both of these projects have. At this point, this is sort of this trifecta of the GraphQL, JavaScript, and ArangoDB, and having worked this way for a while, I can say that for me it's really simplified things a lot. And again, it's hard to talk about something that's like a cumulative effect like this, but I can tell you that this is definitely a thing that I am noticing. So the thing about all of this that I find really exciting here is, for me, trying to build stuff quickly, build systems, move fast, deliver value to the people that I'm working for. I find that speed really requires that depth of knowledge, and I really am excited by the idea that I can really narrow my focus and go deeper into the smaller set of technologies without having to give up sort of I haven't given anything up to do this. I'd also, it's probably worth pointing out too that I really believe that security is a subtractive process, and it doesn't seem to come up very often that you get to remove things from your tech stack, from your network, from your application. But this really seems to be one of those moments when you can actually do this, and really, it's this sort of radical kind of simplification that they've been able to do for the back end stuff, just using these components. So. And kind of GraphQL has been a big part of that. So if I were to try and like sum up kind of GraphQL in a single sentence, I don't know this was, there might be other ways to do it, but I think the thing that's resonates with me is that essentially, I'd sum it up as a schema that lives outside your database. I guess, a definition like that maybe makes you wonder, like, what is this even going to look like? And so essentially it's going to look something like this. So if you have your GraphQL server here on the right, and you can see it's just sending a JSON response back to the client here on the left, right? And then you'll notice the JSON response is just a key of data and then whatever that query produced. So if you look at the query on the top, a lot of people will describe the kind of query syntax of GraphQL as essentially like JSON, but without the values. And I think that's probably a pretty bang-on description. And so the nice thing is that this ends up, the queries kind of mirror the shape of the response, which is a pretty cool thing, helps you think. So I guess what I want to do is show some code to show what it's actually like to kind of work with this stuff. And so if you were trying to actually build a thing that did what was on the previous slide, this is essentially what it would look like. So what you can see here is we're declaring a schema, and we're attaching a query object to this schema, and we're saying that it has a field of hello. So it can have multiple fields, but we're just declaring the one called hello. Now, when a query comes in that includes hello, GraphQL will need to know what it should do. And so the answer to that question from GraphQL's perspective is run the resolve function that we need to provide. So that's what you can see here. And our resolve function is clearly not doing a lot of stuff. It's simply returning the string world. And so this is fairly straightforward, but one other thing that's probably worth pointing out here is that just the line above that resolve function is going to be the return type, the type of object that is going to be that GraphQL should be expecting that resolve, the execution of that resolve function to produce. So this is you get a sense that there's a bit of a contract here that we're signing with GraphQL. So with this schema created, what we'll need to do below, we're going to need to create a query, and then the obvious next step is we're going to want to execute that query against our schema. Now to do that, what we're going to do is pull in the GraphQL function from the GraphQL library, and then we're going to use it literally, by passing those two arguments, the schema and the query, in to be evaluated. And what comes out here is exactly the response that we saw in the previous slide. So most of the time, to do kind of interesting things with GraphQL, most of the work that you're actually going to do is going to involve you accepting like arguments in from the outside world, right? Accepting parameters in. So what we're going to do here is adjust our schema so we can use some of these arguments. So to do that, we're going to dig into the arguments to the resolve function, so the first argument here is the root. In this particular context, as the first resolve function directly in the query object, this is not going to be super meaningful here. Basically just an empty object by default. So we're going to skip over this to the second argument, which is actually the one we're after. So this is the arguments, the args object, and so any arguments that are passed in to our along with our query will end up as attributes of this object. So for that to happen, though, basically GraphQL is going to expect us. We're going to need to declare that it's even possible to hand arguments into this field. So to do that, we've declared that there are going to be arguments. We need to give them a name, in this case adjective, and we're also going to need, because it's GraphQL and everything has a type, we're going to have to declare what type this argument actually has. So in this case, we're expecting a string. With all of that now declared, what we're able to do now, this adjective, whatever is passed in as adjective, is going to be available to us as an attribute on the args object, and so we're going to be able to use it like this. And just in this case, doing a simple concatenation of whatever the adjective is plus world. So if we modify our query a little bit, we can basically, we can get this query that looks like this. So essentially what's happening here is we are passing a named argument in. This maybe if your eyes are calibrated to JavaScript, this might look a little weird. But if you are coming from Ruby or something, this looks totally normal. But basically it's a simple kind of function invocation vibe, and this does exactly what you think it might. So just passing it in and using it to concatenate those two strings. So it's worth pausing here for a moment. We've just done two little tiny examples of using GraphQL, but it's worth pointing out here that there was no database involved with either of those things, right? This is just straight up JavaScript, no database involved. And so it's worth pointing out that like GraphQL, from its point of view, its responsibility ends at the resolve function. So you have, in your when creating the schema, you have to declare what kind of type this resolve function is going to produce. How you produce that is not GraphQL's business, and so there's a real clean sort of separation of responsibility there. All that said, it's basically, in most cases, the thing you're going to be doing in these resolve functions is actually going and pulling from a database. And in my case, and I think maybe the case for a lot of us listening to this will be, we're going to be pulling from ArangoDB. So what's that going to look like? So if you've been using ArangoDB for a little while, you might have noticed in the administrative interface when you're creating a new graph, there's an option here to create some example graphs with a little sort of pre-done test data. And this is perfect for this kind of thing where you want to sort of explore some idea, right? So this is exactly what we're going to use it for. So in this example, I'm just going to create the nose graph, and this is basically what that gives us. So the nose graph is a tiny little thing. Basically, you can just see here, there's 5 vertices here, and just a handful of edges between them. It's worth pointing out, just because it's going to show up in a couple of the examples, that we have Eve over in the sort of upper right, and she has 2 outbound connections, one to Alice and one to Bob, and you can see Bob has outbound connections to Dave and Charlie down the bottom. So if we're going to start pulling data out of ArangoDB, we're going to need some functions to do this kind of thing. So our first function we're going to define, we're going to call it getPersonByName, which, surprise, surprise, is going to accept a name. And we're just going to use that name. We're going to loop through the person's collection and find a person whose name matches the one we've been given. And I'd love to say I love the readability of the AQL here. That feels like a big win. So this is going to produce an object, a person object from the database, and return it to us. And so the person object is just going to have a name like one of the attributes is going to be a name. In fact, the only attribute really is the name. And so what we're going to do is we're going to create a GraphQL type that is going to describe this object. So obviously the description is fairly simple. The fields that it has is just simply type or name. And it's worth sort of pointing out that it's okay for the object to have attributes sort of above and beyond this. So anything coming out of ArangoDB is going to have those sort of underscore ID, underscore rev, and underscore key, kind of those internal ArangoDB attributes. But what we're saying here is with this type is that the name attribute of this object is essentially the only one that's sort of fit for public consumption. So with this declared, what we're going to do is we're going to create a nice new schema that's going to use this thing. And so what we're going to do here with our new schema is the only field that we're really interested in. We're going to leave all this hello world stuff behind, and we're going to create a field of person. So the person field, what we're doing here is we're declaring that it accepts arguments. The argument it is expecting is going to be name, and the type of that argument is a GraphQL string. It's probably worth pointing out here that what we're saying here is that this is a GraphQL non-null, a non-nullable string is the type. So this is essentially GraphQL's kind of equivalent of a required field. So with that declared, we know that we can now access a property of the args object, an attribute of the args object down in the resolve function called name, and you can see that that's exactly what we're doing, and we're passing that name directly into our getPersonByName function. So this function we know is going to go rip through the person collection. It's going to pick out a person and return it. The final thing I'll point out here is we have said that the type, the return type of this resolve function is of type person. So essentially, whatever comes out of this resolve function is as described by the person type. So with all of that sort of plumbing done, what we're now able to do is write a query that looks like this. So you can see here that we have our person field, and we're passing in the name Eve, and we're also needing to say what attributes of the object that we would like returned to us. Potentially there, in probably normal cases, there would be many attributes, and we only get the one that we explicitly ask for, which is one of the very cool features of GraphQL. So with that query in hand, what we're going to do is execute that query against our nice new schema, and what comes out is basically what you might expect is name of Eve. So that's by itself sort of an interesting kind of sort of experiment to get all the plumbing going, but where things get actually more interesting is when you start getting related data and getting the rest of this graph. So to do this, what we're going to do is with the assumption that we will have already pulled something out, like one of these people objects, a person object, out of the database. What we're looking to do is get data related to that object. And so what we're going to do here is define a new function called getFriends that accepts an ID. And what we're going to do here is, what you can see here is we're using the AQL traversal syntax. Again, a big readability win for AQL. To go and starting with this object with that ID, we are going to look through outbound edges in the nose collection and just return whatever vertex happens to be on the other side. So with that function now defined, we're going to turn our attention back to the person type. Because what we're going to want to do here is make some modifications to actually use this function. So the modification we're going to make here is we're going to add a new field called friends. And in this, you can see in here in this new field, this is not obviously a field that is going to exist on this object. When an object of person type is produced and we ask for the friends of this object, GraphQL is not going to find this as a natural sort of attribute directly on this object. So we're going to have to supply another resolve function that's going to have to produce whatever it is that we care about. And so this is this moment where we supply our resolve function and use our getFriends, the getFriends function that we've just created. So you'll probably notice here that this is the reemergence of our mysterious root argument. That's the first argument to our resolve function. And what I passed over it before because at that moment when it's at the root, kind of the first resolver that gets run, it's sort of an empty object and you don't need to worry about it. But this person type will only be evaluated once a person object has been pulled out of the database. And so root at this moment is that person object that we just got out of the database. So that means that it's going to have, because it just came out of the database, it's going to have an underscore ID attribute attached to it that we can then pass in to getFriends. And that is going to be the starting point for our traversal. So with that said, we can make a modification to our query. So here we have our same person query, also passing the name of Eve, asking for the name, but now we're able to ask for the friends of Eve. And if we were to execute that query against that schema using our handy GraphQL function, what comes back is this. So this is basically what I pointed out originally, right? That Eve has 2 outbound connections to Alice and Bob, and you can see that kind of reflected in the data here. But there's something actually even cooler that we can do. So because of the sort of recursive nature of GraphQL, without writing any other code, we also get to write a query that looks like this, because we are returning an array of objects of type person, and person objects have a friends field that you can query. Is totally legit to then ask for friends of friends in this manner. So if we were to execute this, again, GraphQL function, in goes the schema inquiry, and out comes this. And this is essentially the entire graph at this point. With very little code, we've actually produced this this nice little object graph. We walked across the whole thing. We know we're able to get, assuming that there were other properties on these objects, we can ask for any combination of any of the things that we've defined. And GraphQL knows how to sort of satisfy these queries. This is like a really, really powerful thing. Now, looking at this data, it's probably a fair question and a good moment to ask, well, how did it actually do that? Which actually then turns us towards discussing performance and a sister project that Facebook has released called Data Loader. So if you were to fire up TCP dump and watch sort of all the little chatting back and forth between your application and the ArangoDB database, what you would see is this. So you can see our initial, this is exactly that same 3-level query that we just ran, right? And so this is sort of how that sausage got made. So you can see at the first level when we ask for go find me someone whose name matches Eve, right? You can see this is our get person by name function that's getting run. And we know this is going to produce the Eve object, right? So now we'll have Eve and Eve's ID. And so because we've asked for Eve's friends, which are going to be Alice and Bob, you can see we're executing that next, doing the traversal, and we know this is going to return Alice and Bob. And we can see that this is actually, because we've asked for the friends of friends, you can see then that this executes 2 more queries to get the friends of Bob and then the friends of Alice. This is pretty cool, but the trouble here is that in this moment we have created what's known as the n+1 query problem, and this is sort of well known to anybody who's worked with Rails, and they forget to kind of include, automatically join these tables together. So you end up with some query that asks for some parent record and then needs to make multiple sort of this cascade of other database queries to get all the child objects. And so this is a really notorious way to really pound your database into the ground. ArangoDB is really, really fast, but no matter how fast it is, there's, given enough data, it's not going to be able to save us from ourselves. So it won't surprise you at all that Facebook is not any more excited about n+1 queries than we are. So what they've come up with is data loader. Now, the way data loader works is that it essentially it makes really smart use of the way promises work, and what it does is it replaces replace any of the calls that would actually sort of touch the database. You would replace it with a call to the data loader's load function, and what it will do is it will just pass out promises. And then after sort of all the work is done and we're waiting to resolve all these promises, what it will do is it will take a function that we give it and use it to get all of the data that we're looking for all in a single query. And so what they do is this function, this magic function that we're supposed to give it, is called a batch loading function. And you can see the definition up at the top here that's taken directly from their website. A batch loading function accepts an array of keys and returns a promise which resolves to an array of values. So with ArangoDB, what this would actually look like would be something like this. So we have a function here that we're creating called getFriendsByIDs. It accepts an array of IDs, and what you can see in here in the AQL, we're just iterating over this array of IDs and running exactly the same AQL traversal that we were doing before, once for each ID. What comes back is a promise that resolves to an array of values, and so data loader is now happy. So what does it look like to actually use this then? So essentially, especially as your schema gets bigger, you're going to have resolve functions all over the place. What you're going to want to do is make sure that your loader is then available in all of these resolve functions, wherever they may be, in your types or wherever. So what we need to do, GraphQL actually has a facility for doing this kind of thing. It's called like the context. So what you can see here is that whatever object that you pass in as the 4th argument to the GraphQL function will end up as the 3rd object, or the 3rd argument to every resolve function in your schema, which, at least from the perspective of the resolve functions, essentially makes this thing kind of a global. So this is a great way to give ourselves access to this friend loader so we can use it whenever we need to pull up friends for an object. So in anticipation of that friends loader being passed into the context, we're going to make a modification to our person type. You can see here we've added that third argument, the context. And what we're doing here is we are accessing the friends loader via the context, and we're calling load and just passing in the ID of the root. So basically the same idea. Now, if we were to go back and rerun this same 3-level query, and you can see here we're like creating a new data loader, calling it friends loader and passing it in as a context. When we execute this GraphQL function, what we are going to see is this. So if we turn back to TCP dump and sort of explore, this is what happens. So remember, before we had 4 different queries, but you can see already we're down to 3. You can see the original, the first query is still this sort of get person by name, where we supply the value Eve, and we know this is going to produce Eve. And then we're asking for the friends of Eve. And so this is the first time you can see our batch function being used here. And so what we're seeing here is, I mean, essentially it's a batch of 1. It's technically the smallest possible batch. So it's not the most exciting part of it, but the next call is where we start to see the batching kind of winning us something. And so you can see now Eve's friends, Eve has 2 friends, and that we know that query is going to return 2, and you can see the 2 friends that were otherwise going to result in 2 different calls to the database are now batched together and handled in one query. So what this gives you is essentially, one database query kind of per query, per level in your GraphQL query. So with the n+1 monster slain and or vanquished, what we were able to do then is turn our attention to serving our nice new schema to a grateful world. So what we're going to use to do this is ExpressJS. Now, the people that have built GraphQL have also turned their attention to making a nice integration with ExpressJS. And the way they've done it is this is all there is really. So the main event here is this app.use call. And the way they've done this is they've basically created using exactly the same GraphQL function that we've been exploring and using through all these little kind of examples. All they've done is just wrapped that in an ExpressJS middleware, and all you need to do is import it and call app.use and pass in your schema. So this is one of these really kind of happy anti-climax moments. So that's really the thing that I kind of want to show you with GraphQL. I think it's really, really powerful, but I think there's a kind of a neat sort of realization that comes to you once you play with this a little bit, which is that sort of description I gave at the beginning about like it's a schema, but like outside the database. Really, as I thought about it, really took on a sort of a deeper meaning here, right? Because if you give it some thought, now, like there's been a long ongoing conversation about sort of schema-less versus schema and, in the NoSQL world, right? But now this is not, with the advent of GraphQL, this is not a kind of a yes-no question anymore. This is not a, yes, I want a schema, no, I don't. This is now a question of like, well, where would you want your schema? Because what we've been able to do is pull it right out of the database and put it directly on the server. And so what this really is a kind of a powerful idea, because a schema outside the database really gives us a chance to apply this schema across multiple systems, which is a very powerful idea. And it also means that we're able to, because this is the first thing that executes, the moment a query arrives at our application, those schema constraints are essentially enforced before any other of our code is even executed. So we're able to catch bad input right at the application boundary, well before any of our code is executed and long before it touches any of the systems behind us. And this is a really, really powerful tool. So it's also worth pointing out here that this is also a sort of a resolution to this kind of choice that one might often feel that one needs to make between sort of choosing this a rigid schema versus this flexibility generally of the kind of document model and the graph model, and really specifically ArangoDB, because now essentially you can just say I'd like both, please, and that is totally an option. And so this is a really, really powerful thing. So if I were to leave you with a thought here, what I would say that is the kind of the idea here that connects these two projects for me is this idea that you have really powerful, really flexible tools that unlike a lot of other projects, these are not things that you simply add on top of every other thing. Both of these projects really represent a chance to actually remove other things from your tech stack, and that is a really powerful and sort of exciting idea. So what I would say is essentially that this is an opportunity that I'm super excited about, and I would encourage you to also seize this opportunity and build more things with fewer things. So if you're excited about GraphQL, I would encourage you to go and dig into their website. They have wrapped the Swappy API. This is the Star Wars API, which is a REST API, by the way. They've wrapped it in GraphQL, and you're able to sort of write GraphQL queries and explore, pulling back the data, see what it looks like and stuff. It's a really great way to kind of get your feet wet and sort of understand what it feels like to write these queries. I know that if you're interested in GraphQL or in ArangoDB, they very much appreciate if you're wanting to start them on GitHub, and if you're already using this kind of technology there and have stuff to say about it. They're certainly looking for other people to, present at these meetups. So if you're interested in kind of what I'm up to, these are various ways of contacting me. I'm on GitHub, Twitter, or you can use old school kind of email, which I also respond to. And with that, I will leave you and thank you very much for your time and attention.